multiple senses, sensory experiences can create a more believable and engaging virtual environment. In a previous chapter we discussed various basic design elements. However, in immersive design applications, users move in 3D space and interact with objects and characters through gestures and controllers. It is therefore important to make sure that your designs help users to understand how their virtual bodies relate to the virtual space. Some principles that you can keep in mind are: prioritize user comfort to prevent motion sickness. Use natural, intuitive controls. Provide clear visual, auditory, and haptic feedback. As you can see in this video example, the user's hands are shown in the VR training video to provide visual feedback of the user's actions and help the user to orient themselves in relation to the objects in VR. When designing for XR experiences, understanding the principles of depth, scale, and orientation is crucial to creating immersive and believable virtual environments. A sense of depth can be created by representing 3 axes on a 2D screen. However, some VR headsets use stereoscopic views to enhance the realism of the 3D experience. Stereoscopic views are when each eye is shown a different image of the same scene, taken from a slightly different angle, to simulate the distance between your eyes. However, monoscopic video is also used for VR and is more versatile because an HMD is not required for the experience. Similar design principles are relevant for both types of view. The illusion of depth for monoscopic views can be created by strategically using visual depth cues such as linear perspective, atmospheric perspective, occlusion, and parallax. Occlusion refers to when objects can be partially or fully hidden by others, creating a sense of depth and layering. The illusion of depth can also be created through linear perspective, where objects appear smaller as they recede into the distance. In this image you can see several spheres in a room. We know that the large pink sphere is behind the smaller spheres because the smaller spheres overlap, or occludes the shape of the larger sphere, creating the illusion that the smaller shapes are in front of the larger shapes. The converging lines also create the illusion of a room with depth. Perspective also refers to the simulated angle of view that is presented to the user. A wide angle of view allows the user to perceive spaces with peripheral vision, but that also means that vertical lines will converge more, and shapes might be distorted. A narrow angle of view has the effect of being zoomed in on a smaller portion of the scene, and space will seem compressed, but this allows focus on details and less distortion of shapes. Atmospheric perspective involves reducing color saturation and contrast as objects move further away, simulating the effect of atmospheric haze. In this image you can see how atmospheric haze is used to simulate depth. The ship and the waves in the foreground have a lot more detail and texture than in the background. The colors and tonal values in the background are also lighter and less saturated than in the foreground. In this video you will notice that the trees in the background are moving much faster in relation to the frame or the user than the trees in the foreground. This effect is called the parallax effect and can be simulated in VR. Parallax refers to how objects at different distances shift at different rates as the user moves, providing a strong depth cue. Scale is an important aspect of spatial awareness. Human scale. Objects should be scaled relative to the human body to create a sense of realism and comfort. Proportion. The relative size of objects within a scene should be accurate to maintain a believable environment. Hierarchy. The scale of objects can be used to emphasize or de-emphasize certain elements, guiding the user's attention. We will focus more on visual hierarchy in the next part of this chapter. Scale, relative size of objects, and proportions come into play with foreshortening. Foreshortening is when parts that are closer, belonging to the same object or figure, are rendered bigger in the frame to indicate closeness. In this image of a welder holding welding electrodes, the arms seem very thick, but it makes visual sense because we read them as being closer to us. Scale is an important aspect of spatial awareness. Ground plane. A clear ground plane helps establish a sense of stability and reference. Horizon line. The horizon line provides a visual reference for distance and scale. It also allows the user to orient themselves and provide visual feedback of head movements on HMDs that track head movement. Lighting and shadows. lighting and shadowing can help define spatial relationships and create a sense of depth. By carefully considering these principles, designers can create immersive and believable XR experiences that transport users to new worlds. The horizon line also allows the user to orient themselves and provide visual feedback of head movements on HMDs that track head movement. The horizon line is an important tool for visual feedback triggered by user actions and movement. Lighting and shadows are very useful visual tools to help you orient the user and objects in the scene in space and time. Shadows and light can also orient the user in terms of mood and atmosphere. Light is used to simplify a scene but can also complicate a scene unnecessarily. In this image of a 3D sphere, the silhouette lighting emphasizes shape over volume, but simplifies the visual design and creates a less cluttered image. Sometimes creating a 100% realistic scene can be confusing because all the objects are rendered with the same level of detail, making it difficult for the user to know where to look. In the example of a VR training video, screen grab the realism is necessary, but it does make the scene very busy, especially if the user is moving and looking around in the scene. The brightly lit passages contrast with the darker walls in the background to help define shapes. However, some of the boxes in the distance are brighter than those in the foreground, drawing the eye away from the foreground where the user is required to focus. In the next chapter we will discuss hierarchy and how visual design can be used to direct the user's attention.